So in this video, I'm going to go over problems that are similar to what's on your Unit 2 writing assignment. So let's look at this first question. This is similar to what you have on your Unit 2 writing assignment. So in part A, it says, what is the axis of symmetry of this function? So remember, the axis of symmetry for a parabola is a vertical line that goes through the middle of the parabola and divides it into two even parts. So since it's a vertical line, it's going to have the equation x equals a number. So in this case, if we look at this line, we can see that it passes through -1, and everywhere along this line, the x-coordinate is going to be -1. So x equals -1 is the axis of symmetry of this function. So now we're going to look for the coordinates of the vertex. So remember, the vertex is the turning point of this function. So right here is going to be the vertex. So if I read the coordinates, that'll be -1, 4. So now it wants to find the coordinates of the x-intercepts. Remember, the x-intercepts are where your graph crosses the x-axis. So it crosses here at these 2 points, and if I write out the coordinates, that is going to be -3, 0, and 1, 0. Now for the y-intercept, that's going to be where your graph crosses the y-axis. So it crosses the y-axis at this point here, so that point is going to be 0, 3. So in this question, it gives you two functions. So this function f of x equals x squared and g of x equals 3 times x minus 3 squared minus 2. So we need to do in part A is describe the transformation. So remember, what we do is we look at the equation and look at how the numbers are going to affect the shape of the graph. So if I look at this equation, this 3, this -3, and this -2 are going to affect my graph. So this 3 is in front. Since it's in front of my equation, it's going to be a vertical change. And what it's going to do is it's going to be a vertical stretch because it's a number that's bigger than 1. Now I have this -3 that's on the inside. Remember, changes that are within my parentheses or within the square are going to be horizontal changes. So this is going to be a horizontal shift, right 3. Okay, because remember, if it's minus, it goes to the right. Then I have this -2 at the end, and that is going to be a vertical shift because it's outside my parentheses, so it's going to be a vertical shift down 2. So then what you can do is you can use your graphing calculator to help you approximate what this graph is going to look like. Remember, first we're going to graph the original parent function, y equals x squared. So it opens upward, it's centered at the origin, and something like that. And then this new function that's going to be shifted to the right and down 2. So it's going to be right 3 and down 2. And it's also going to be narrower than my original parent function. It's going to look like this. I mean, you can just approximate. So in this question, it gives us a table of values relating the soil density to different depths. So we have to write a quadratic regression equation, and it tells us to call depth our x value. So that's going to be what we enter into L1, and soil is our y value. So that's what we enter into L2. So what we need to do to solve this and find the equation is we need to use our calculator. So you go to Stat, and then hit Enter on Edit, and enter these numbers into L2. So once you've done that, you're going to click Stat, and then arrow to calculate, and we're going to choose option 5, which is quadratic regression. So once you choose quadratic regression, hit enter, and then hit enter on calculate, and then it's going to give you the coefficients of ax squared, bx, and c. So it says y equals ax squared plus bx plus c, and it gives you the a, b, and c values, which I'm going to round here. So you have -0.57, b is 25.32, and C is 1005.12. So what we need to do is we need to write it as an equation for it to be our final answer. So it's -0.57 x squared plus 25.32 x plus 1005.12. So now in part B, we need to estimate the soil density of a sample at a depth of 20 meters. So if depth is 20 meters, that means x equals 20. So we plug into our equation, so we have negative 0.57 times 20 squared plus 25.32 times 20 plus 1005 times 12. So I'm going to go ahead and simplify this a little. So this is going to be negative 0.57 times 400 plus 25.32 times 20 plus 1005.12. So negative 0.57 times 400 is negative 228 plus 25.32 times 20 is 506.4 plus 1005.12. So we add up all these terms. So negative 228 plus 506.4 plus 1005.12, and we get 1283.52. So that is the soil density, so 1283.52 milligrams per centimeter cubed.